Hey everyone, hope you are doing awesome. Welcome back to my channel PEGAhut with another video. Thanks everyone for subscribing to my channel, and if you haven't hit the bell icon yet, please do so you won't miss any of my videos. Please hit the like button and leave me a comment or feedback if you like the video or the way I have explained.
So today we are going to learn about part 3.4. Now what we have learned so far, we have learned part 3.1 where I have explained you guys how to connect with Get API, part 3.2 connect to Post API, and part 3.3 on how you can configure the URL dynamically by using the GRS concept and also by using application setting. So we have covered part 3.1 to 3.3. Now in this video we are going to talk about part 3.4. Now in part 3.4 we are going to talk about all the theoretical knowledge about service package and service REST. I want you to understand then how does that work and what is the rationale behind service package and service REST rule, so that it will be easy for you when you go to part 3.5. Now for service REST, what we are going to learn is service package and service REST rule, right? In service package rule, we are going to learn about context, pooling and open API tab. So we're going to go in detail on explaining each and every functionality of context tab, pooling tab and open API tab, what you're going to see and how you're going to use in real time. For service REST, we are going to learn about service and method and open API tab, and I'm going to explain you in detail. Now, if I come to the introduction of a service package, it's a package which holds all the service. So consider, a kind of a folder, right, where you keep all your document, right? Here the folder is nothing but the service, and the documents are nothing. Folder is nothing but the service package, and the document is nothing but the services that includes in the service package. So whenever you go, what you do, you open the folder and try to access the document, right? Similarly, you have to, if you wanted to access a service, then you have to go by service package. Now second thing is, it's an instance of data-admin-service package class. Now the third thing is, it is a data instance. It's not a rule instance, so you can save it without having a rule set version to be unlocked, right? And the last one is, when you create a service package, system automatically associate with the application rule set from your current application. So basically, although it's a data instance, so what generally happen is, obviously a data instance will be part of your rule set, right? It doesn't need to be a part of a version, but it will be part of your rule set. And generally system, what it does is, based on your application, it will assign to a rule set. If you want to change it, you can change it by clicking on edit. Now this is how it looks like, right? Now here, if you see on the top, you got the ID, which I've just created text for you, and then you have got PEGAhut. Now that is the rule set which I was talking about. Depending on the application, it will take the application rule set. Now here you have context tab, where you have multiple things which we are going to learn in the next slides. Now this is how it looks like. At the bottom, if you see in the method, your service type is rule service -rest, and this is what my service is, which is attached to this service package. Now if you have more than one service, automatically it will be listed down under that service package. So I hope this is clear. Now let's understand about the processing mode of the service package. Now we are going to learn all about the context tab, what all options that I have in context tab, and how we're gonna use it in real time. Now to start with, the first thing is processing mode, which is very crucial. Now processing mode are two types. One is stateless, another one is stateful. Now as you guys know, stateless means it doesn't host the data. So all our APIs, REST APIs are stateless. So what we do is, I trigger a request and I get a response. Now if we dig a bit deeper, it doesn't store any data while processing the request. That's why it is very lightweighted. That's what makes it very lightweighted. Now when we're gonna use the stateless service, if the service in this package can be run by any requester without regard to processing that the requester performed earlier. What does it mean? Let's say requester 1 came and tried to access the service. Now requester 2 came and tried to access the services. Now requester 2 doesn't need to know or dependent on what requester 1 has done. So this kind of thing is stateless. So they basically, like I told before, it's a synchronous call. So whatever requester 1 has requested is gonna go take the request and give the requester 1 a response. At the same time, whenever requester 2 gonna come and try to access the request, it's gonna go and get him the request. So they both are independent. It's like a thread way of doing it. Now the third thing is, when you want to perform a simple calculation, right, where you just send a request and do some calculation and get back the response, those kind of things where you are going to use the stateless service. Now you're just processing the request and send the response back to the caller. That's all you need to do, and it doesn't store anything, and if it fails, it's gonna fail then and there. Now stateful service, it means that it maintains a clipboard structure, so subsequent requester can use the same. Now, like I told earlier, the stateless service does not store any data, right? Stateful service does store the data. Now, stateful service generally means that when you say in Pega that we store a data, obviously we store data in clipboard, right? So that we can access as part of our process. Now, that's why you use the stateful service. Let's say over here you can do configure in such a way that, let's say requester 1 came and then it try to access the service and it does something, and then requester 2 came and then try to access the same service. Now requester 1, whatever they have used it, you can reuse those data for requester 2 depending on the configuration or depending on the need. So basically the only reason when you go for stateful, when you know that you need to maintain the earlier processing data so that later on you can use that. So those kind of scenario you are going to go with the stateful processing mode. I hope this is clear. Now let's move to the next one, which is another crucial thing, is service access group. Now this access group is used during rule resolution to find the correct service rule at runtime. So now when you are using a service package followed by a service method will be there, where you are going to use activity, you are going to use class and everything, right? So now this access group is very crucial, where Pega will take this access group as part of the rule resolution, so that it will find the right rule and process them accordingly. Now it is a mandatory field, obviously, because Pega would not know which rule to pass during runtime, right? So that's why service access group is mandatory. Now in the real time, either application uses an admin access group depending on the need completely, or generally what we do is we create a dedicated service group and assign to the right application, so that this service group will be untouched. I mean during dev phase we generally use the admin access group, but when we push it to production we try to keep it a dedicated access group for this particular service, so that it will be unchanged and nobody gonna do anything. Nobody gonna change it, because the moment you change the access group, if it is an admin access group and you change it, it's gonna impact the service. So we try to keep it separate. I hope you are clear about the service access group. Now let's quickly talk about the authentication, right? Now if you see here, we have require authentication, right? In require authentication, what does this mean? That means if you select this one, right, Pega would expect you to pass a user ID and password. Now in Pega, what is user ID for Pega is nothing but your operator ID. So when I say require authentication, generally what I do is I create, you can literally use any operator ID and password, but think about this consumer, right? Obviously you are not going to give your operator ID and password for consumer to access, right? So that's why we create a dedicated operator ID and password, and then that password will go as a basic authentication for the consumer, so that they can use that, and based on that they can access the service. Now if you don't want them to use the authentication, then you just need to uncheck. The moment you uncheck, what will happen is the authentication type will not be visible. Now here the user ID and password is nothing but operator ID and password, which I have already explained you. Now in the authentication type, as you could see, now in the drop down of basic, I have mentioned there are three type of authentication mechanism. Now one is basic, which is your operator ID and password. Another one is OAuth 2, and the third one is custom. Let's dig a bit deeper about what is that basic, OAuth and custom. Now for basic, we are going to use the operator ID and password, which I have explained. Now for OAuth 2, OAuth stand for open authorization. So it is a way that we authorize a service. Now OAuth is widely been accepted and been used, and I have a plan to create a separate video because there are many ways that you can use the OAuth, so which will be coming in next few weeks or so. So just stay tuned for that. But for the interest of time here, I'm just going to explain you that OAuth stands for open authorization, a way of connecting client and server without basically sharing the password. So basically by using OAuth, you do not need to share the password of a specific this one. It will be used as a token, and based on the token you can access the service. Now for custom, let's say if custom, generally what happened is when you provide a authentication like LDAP or some other way of doing, then you can go for custom. Now the next thing is about required TLS or SSL. Now, if you know that TLS stands for Transfer Layer Security and SSL stands for Secure Socket Layer. So what does it mean? If you select this, the caller must use HTTPS, only applicable for basic authentication type, not for other authentication type. Now let's say what does it mean by HTTP? Means the request is coming in a secure way. Now let's say you chosen this option, but however the caller is trying to call by using HTTP. During that time, Pega will forbid that request and will send a 403 error HTTP response code back to the consumer. Now I hope this is clear. Now next move to the next one, which is suppress show HTML. Now what basically it does, it will skip. So as part of this service package, it will call a service. Now in the service you might call an activity, and in the activity you might say show HTML. Now if you see, it doesn't make sense because it's a service, right, which we are going to send a response back to the consumer. We don't need to show any HTML method, right? And that's the reason why you need to check this always, so that it will suppress all the show HTML method if at all there are anything that you have used, or if let's say if you are using any Pega OOTB where they are also doing that OOTB showing the HTML method. Let's try to understand the next tab called pooling tab. Now before understanding pooling tab, let's I'll probably give you more insight about how the service execution works. So let's say you created a service REST, right, and you expose a service to the external party. Now when external party, let's say you are trying to hit via Postman, right, and trying to test this API. So the moment you hit in the Postman, the moment it reaches to Pega or the service package, or Pega, what Pega does internally, it basically create a requester, because somebody has to process that request, right? Pega is going to create a requester depending on the access group that you have given, and that requester is going to be responsible for processing that request end to end. So when I say end to end, means it takes the request from customer or consumer, and then it processes the request and it takes the response from the provider and then gives back to the consumer. That means whoever calls, it takes the request from them and gives the response back. Until that requester will be engaged from end to end process. So that's how Pega executed those service from those service package. Now that is why pooling is going to be a very important concept, and you need to really understand on how you're going to configure that. Now first, before we go, we need to understand why requester pooling need to be created. The reason is, by enabling the requester pooling, you are going to improve the performance. Now you'd be thinking, how are we going to improve the performance? Now let's understand, the requester pool is nothing but a set of requester, right, that are reserved to use for this specific service package. Now when I say, okay, so if you see, for if you create 10 service packets and each service package has got like 5 services. Now when I say pooling, means it is dedicated for that particular service package. Now when you create a size, means those requesters are dedicated for that service package. So anytime somebody comes and hits, it's going to execute that service. Okay. Now as the requester are reused, right? Now when I say requester are reused, it is inside the service package. Let's say here, if you see, the ideal requester is 10. Now they all are reused and they share their resources. So that means they can, if they are free, they're gonna just pick the one request. Let's say if request come, they are going to pick that and going to process it, and after that they'll be ready for another request to process. So that's how they're gonna work, right? Like machine. So because of that reason, what happened is, and the requester is already there when the moment request comes, right? That's why service need not to wait for a requester to be created, and because of that it saves a lot of time, because creating a requester obviously gonna take some time, right? Now but here what you are doing is you are already created that pool and get ready for the request to come. So because of that you save a lot of time, and because of that how you improve your performance. Now you can enable and disable this requester pooling by using the DSS. So the DSS name is enable requester pool. So it can be true or blank. When it is true or blank, requester pools are enabled. When it is false, that means requester pools are disabled. Now I hope it's clear. Now let's try to dig a bit more about the respective ideal requester, active requester, and the wait time. How does it work and what is the significance of that? Now maximum ideal requester, what it does basically, it denotes the size of a pool. So it's a pool size where you got 10 requester, because I have mentioned 10 over here. Now if you don't want to set a specific size, right? If you wanted to make it unlimited, then you can set it to -1. Now let's jump into the maximum active requester. Now the number denotes how many concurrent requests the system will allocate to the services of the service package. So what does that mean? Let's say if I define 10, that means at a given point of time, only 10 requests can process parallelly. So that means this 10 request is going to be activated at a given point of time. If there are more requests, it has to wait. Now when the service request arrives, right, while the number is at the maximum, let's say you are already reached, you have defined 10, and now you have already 10 requests going in parallel, right? So that means there is no room for it to pick another request. It has to wait. So the system has to wait for the ideal requester, as it can't create another requester, because what you told your ideal requester is 10 and maximum requester is active requester is 10, right? Now let's say in a scenario 10 requests came at the same time. So that means all the ideal requester got engaged in that request, and now they became an active requester. Now let's say if another service come, that means do you have any ideal requester in the pool? No, I don't have any ideal requester in the pool, right? That means the service has to wait, and now my active requester are going the moment one active requester finish the job, it will again come back and take the next waiting request. Now an active requester became an ideal requester once it finishes the execution of the service. Like I just mentioned, the moment you finish an active request finish the service, it will come back and sit in the ideal pool size, and that's how it can take another request the moment another request reaches to it. Now if you want to have an unlimited active requester, just set to -1. Now let's understand about the maximum wait time. Basically it is time in second for system to wait to assign a requester when a service request arrives. If the ideal pool size is 0, that means it has to wait for that particular time, so that once the active requester became an ideal, it will pick the request and go. So this is how this is the theoretical part, right? Now let's try to understand how does it work, right, internally, right? Now let's say when the request come for the first time, let's say now you created a service package, you triggered one request and it reaches for the first time, right? Now to execute a service from the package, right, a new requester will be created and process this requester as an active requester. So first time it will not, there won't be any requester. A new requester will be created and processed as an active requester. Now once that requester finishes, right, so it will come back to ideal requester pool. So that means initially when it created, the ideal requester pool will be 0. The moment a requester will come, it will be Pega will create for the first time, and then it process, and again now the ideal requester pool size will be 1, right? Now let's say you trigger another request second time when it comes, right? A requester comes to execute the service from the package. What Pega does is Pega first goes and checks, in generally Pega goes and first check whether you have any ideal requester in your ideal requester pool. If the requester is present, then Pega engages that requester. If it is not present, what Pega checks is if the total number of active requester is less than ideal requester pool size, and then based on that it creates a new requester, else it wait until the active requester is free to be engaged. So basically again if I'll just explain it. So what Pega does is Pega when a request comes, first thing Pega checks an ideal requester. Now let's say ideal requester is 0 at the moment. So what Pega does is Pega creates a requester, assign that request to the requester so that this requester will go and work as an active requester and then come back and sit in the idle requester. Now next time, let's say there are two requests came into Pega. So now what Pega does, Pega checks the idle requester. The idle requester size is 1, right? Then it assign that idle requester to that particular requester and then make that as an active requester so that it can process the request and create another request for the second request. Now after they both finish the job, they will come and sit in the idle requester pool, which is like let's say 2. Now let's say now there will be another 5 requester comes into picture. Now what happened, Pega assigned those 2 requester because that is available, and then Pega process them as an active requester and creates another 3 requester, right? Now while those 5 requester are active, let's say Pega receive another request. Obviously during that time your idle pool is 0, right? Because all are active and they are working on it, right? All requesters are active and they are working on it. So Pega see, okay, now I have total 5 number of active user and my pool size is 10, so I have still room for creating those active more user. So Pega creates another one and then assign them and make another active user. That's how it works, and it processes the request accordingly. Now once it reaches to the maximum, which is 10, right? Let's say I got 10 active requester. Pega reaches to the maximum. That means Pega won't create any more requester. It will wait until this requester will get idle and goes back to the service package. Now I hope this is clear. Now let's understand what are the best practices that we can configure. Now the best practice is that never set maximum idle requester size higher than maximum active requester. I'll explain you why, and so that you can relate this. Now let's say you are in an agile team, right? And you got 10 members of team. Now let's say if 10 members of team are there and then 10 members are going to work on user story, it is good, right? Now let's say ideal requester means team size. Now let's say you got 12 members of team. However, your maximum active requester means at a given point of time maximum people can work is 10. So that means those two extra people which is there in your team is waste of money, right? You are going to waste their time and money, isn't it? So that's why make sure your maximum active requester is always going to higher than the ideal requester size. That means this scenario where you got 10 members of team, you got more user story to do, you are kind of going to borrow 2 more members from a different team and trying to engage them to work on your user story. So that means your active requester over here is 12. However, your team size is actually 10, which is good. But if your team size is 12 and only 10 people are working in a team, that means it's not like you are getting the best performance. So this is exactly like our agile team. So consider that way, and based on that we need to configure. Now whatever I just explained, right? Requester remain unused in idle pool. Like if you got 12 members in your agile team, 2 requester are unused, right? They are not doing anything, right? If an ideal requester value accept active requester. However, on the other way, if you see when an active requester is more, that means you are basically getting more work, right? So that's how you're gonna configure that. Now let's say if at all your service is fluctuating, right, or little unstable, right? So what you need to do is you need to increase your active requester. So for example, is when exactly again try to correlate with your agile team. Now let's say you have a lot of deliveries to be done, but because of team size, less size, you can't deliver more, and for some reason you can't increase the team size. So what you need to do is you increase the active user. That means you increase the number of developer by borrowing 2 developers from another team, so that you can get higher performance, and significantly you are going to improve the performance, and also the response time will be less, right? Now this is how you need to configure. Now let's say for any service request which is consistently having a short interval time, means there are small user story which people are just finishing in within no time. During that time you do not need to have a big team size, right? So that's how you need to reduce the team size. That means you need to reduce the ideal number of requester. That means if you do not have big delivery, right, you don't have need to have 10 members. Depending on the delivery size, you define, okay, 5 members is enough, right? Similarly, if your service package does not have so many requests, or it the response is very quick, you do not need to have a big ideal number of requester, right, which will be unused unnecessarily, which is not good, right? Now the next thing is, for service request with consistently long interval time, right, increase the number of maximum ideal requester. That means, let's say if you got a big delivery to be done, right, and it takes a lot of time for a request to finish. That means you need to have more ideal requesters, so that if at all the active requester takes a little more time, somebody is there to take another request and process them. So you need to increase the ideal number of requester over here. Now how you gonna configure the time? When the execution interval is short, right, from end to end, right, from let's say you are going for a state rest, from starting from request, processing it and getting a response, right, during that time you need to decrease the maximum wait time, because you don't need the maximum wait time to be more, because it's short, right, it's faster. You don't want anybody to wait, so it will be good to decrease the maximum wait. If your execution interval is long, say if it is taking more time, then just increase the maximum wait so that it won't get timed out. Now when you when service reliability required in higher percentage, during that time what you need to do is you need to increase the maximum wait. So what will happen is, the moment so let's say if you decrease the max wait time, right, what will happen? It will time out. That means obviously the consumer will get a 500 error, right? Now but here if you increase the wait, means the request will wait for a requester to be engaged when it reaches to the maximum active requester. So once the active requester finishes, it will come back to ideal requester, means it will pick that request and goes and process that. So that's where you need to increase the wait time a little more, so that the services would not fail. So these are the configuration and best practices that we need to do while configuring the polling tab. It's all depend on the scenario, depend on what kind of business need you have got. But before that, you need to understand on what this field significance and how does it work. Then it will be easy for you to configure. Now I hope this clears your concept about polling, and we will go to the next, which is our Open API tab. So this Open API tab, I was working in I am working in 7.4 at the moment, to be honest, and I know for a fact that it's doesn't. I mean, Pega 7.4 doesn't have this Open API tab. It has come into picture in Pega 8 version onwards, and it's a cool feature where whatever service package that you define, basically we call this as a contract, so that you can say this Swagger file to your consumer so that they can use that. You can also say this YML file to your consumer so they can read. And from this Swagger file also, so if you see, there are two tabs, right, in Open API. One is YML, another one is Swagger. YML is purely code, and Swagger, so in my API basic video where I have explained how the code base looks like, how the visualization part looks like. Now if you see the Swagger here, you can directly go and test it instead of how you do this test by using any Swagger. Here directly you can go and test it. Now moving, so this is pretty much about my service REST. Now we are going to discuss more about this is pretty much about my service package. Now we are going to discuss about our service REST. Now in service REST, let's understand about the introduction. It is exposed as a Pega REST service for consumer to consume, right, which we know already. Now it is an instance of rule-service-REST. Now it is a rule instance, that means it needed a rules version, and you cannot change it anything in production. Obviously you need an unloved rules version. Now here, when you create a service REST, we need to have this below information which are mandatory for creating a service REST. What is the information? First is service name and version. Second thing is service package name. Third thing is URI template. Now you remember one thing, that service package is the first thing that you need to do before you create a service REST. That's how it works. Now you create a service REST, you create a service package. While creating service package, tell which service you create a service package, you create a service REST. While creating service REST, tell which service package you want this service REST to be part of. That's how it's gonna link together. Now URI template is nothing but the if you remember, I have explained you the URL of an API in my previous API basic videos, where I have explained you how you're gonna configure URI, how you're gonna for get route, how you're gonna do for post route, how you're gonna do all these things is nothing but a URI template. Basically, you define this URI template, automatically Pega creates an URL for you depending on the service package that you use, which we are going to see in the subsequent slide. Also, we are going to do practicals, so don't worry about it. I'm going to talk more about when we're going to do the actual practical on how you're going to define the URI template. Now service REST look like this. So when you create a service REST, so it looks like this, where you have got the service tab. In the service tab you got resource property and processing option. Now let's dig deeper about these particular tabs and their significance. Now when I come to resource property, okay, so first thing is you see resource, right? Now what is this resource? Means this is a class basically. So the class name is nothing but it is a class name of a primary page. So right, when a request comes, that means this is the class where you got all the request and response stored. And Pega assign a requester, and you can use the primary word in Pega so that you can use all the properties, request and response property. Now generally this will be mapped to a data layer, right? I'm just creating in the work layer, but generally it will be mapped to a data layer. All request response field will be created under this class for Pega to expose. Now this is about resource. Now next thing is service endpoint URL. Now this service endpoint URL is the endpoint URL which your consumer has to use. Now if at all you have used the SSL to be on, it will be HTTPS. If you haven't used the SSL to be on, it will be HTTP. But most likely in real world, it will be always HTTPS. Now this URL gets configured exactly the URL which I have explained you in my API basic, where you have the HTTP or HTTPS, and then localhost port number, and then the URL. In the URL you will have service version, service package, and the template. Now here if you see this employee -temp1, right, this is called URI template. Now this, when you give this URI template while creating a service, right, it automatically Pega automatically form this URL depending on the service package and the URL. Okay, now this URL template which we have entered while creating the service, right? I hope this is clear. Now next we can understand about this temp1. The moment I create anything in the bracket, if you remember, I have explained that previously in my API basic, the moment you put anything in the bracket, that means it is nothing but a variable name. Now here in the URI template, the way you see employee is hard-coded / temp1 is in the bracket. That means temp1, I'm considering it as a variable. So when a consumer is going to call this service by using this URL, in temp1 I would expect them to pass a particular request. Now here the request, what I'm doing is at the bottom, because it's part of our URI path, I'm going to assign that request to clipboard. So here you see map to clipboard and map to key. So you need to map where, you need to define where you are going to map, and you need to define which key you are going to map. Now this key can be a parameter value, can be also a request object created by you. So we're going to do practical about it, but just understand here. Let's say in map to value, let's say I've chosen clipboard. Now map to the page name or property on the clipboard specified by the map to key field. Now here in the map to key field, you basically going to give a property name. Now this, let's say if you are using a property name, this property will be belongs to the class that you have used under resource, right? Now you can also use a parameter name, so that Pega create a parameter page during runtime, as you guys know, and you can also assign from that parameter page also. So depending on your configuration. Now in map 2, let's say you are going with automation input. If you use an automation input, then you need to also use an automation to implement the method, right? So I'll show you where exactly you are going to do on a theoretical basis, but in practical we are going to use the clipboard structure only. Now moving to the next, processing mode, right? So there are certain options that you can see. Let's quickly dive deeper in what these options are. Now end requester when done. So what does it mean? And so I mean, as you know, I've already explained. Whenever a service or request comes to Pega assign a requester. Now here we are telling end requester when done. Now this is only valid for stateful. For stateless, the moment it processes the request, got the response, deliver it back to the consumer, that means the requester get automatically end. It is basically active requester get automatically end and goes to the idle requester pool. But this is required only for stateful services if you want the requester to be end. Now the next step is the method is read only. Now if this is selected, each use of this service does not count as a service invocation under the terms of your license agreement. Now if you want to dig more detail about license agreement, then feel free to go to PEGAhut and get all your information corrected. But generally, in general, we don't want this to be, generally we want every service invocation to be calculated and noted. That's why we never choose this option and we always make it unchecked. Now going to the monitoring, the name itself indicate if you want your service to be monitored, then please feel free to set this option to on, and then if you want to also capture the clipboard while monitoring, then you can also choose that as well. And the last one, which is the service package link. So this is just a link been given so that you can direct to service package directly from the service. Now moving to the next one, which is the execution mode, where there are three kind of execution mode. One is execute synchronously, another one is execute synchronously queue on error, and the third one is execute asynchronously queue for execution. Also underneath you will find a request processor, so they kind of linked with each other. So let me explain you in detail. Now for execute synchronously, for synchronous request, it would what it does basically, it takes the request and it gives you back the response, right? So when for all the REST service or stateless services, it is always going to be execute synchronously mostly. Now let's say, for example, if you got an error while you are executing, right, and you are trying to retry that error and retry that service by using somewhere, right? That somewhere is nothing but the second option, where execute synchronously queue on error. The moment you choose that option, so what it happens, if synchronous request fails to process, then you can queue them into a asynchronous execution. Now to queue them, that's where you need this requester processor. So that what will happen, what Pega does is, if there is an error, it will whatever requester processor you would have defined, Pega would try to assign them. Now execute asynchronously queue for execution. What happen if you select that option? Now this option is generally when you want the service to queue the request for asynchronous execution. Now synchronous, your requester will take the request then and there and get the response back, but this is something asynchronously you want to execute. Now basically it will be queued, right? So that it will be executed in asynchronous way, so that the caller does not need to wait for that. Now because of that, what happened is, instead of getting the right response, because it's asynchronous, what Pega provides is the queue item ID back to the external application. Now this option also required the requester processor. Now if you see this requester processor, for both execute synchronously queue on error and execute asynchronously queue for execution, they both kind of executed asynchronously only. Now because of that, you have to define a requester processor, and this requester processor belongs to data-admin-requester processor-service class. Now this option, what it does, the moment you assign that, Pega will create a queue item ID and provide back to the consumer, so that the caller, so that later on they can use that queue item ID to pull the detail. Now the last point which I wanted to mention with respect to requester processor, in the scenario where you have chosen execute sync queue on error, right? So what it does, it can have the ability to hold both error and the clipboard data and returns the queue item ID back to the caller so that it can be processed by an agent or the system administrator at a later point of time. The next thing which I wanted to discuss about the enabling the service SLA with a fallback activity. So the moment you enable the service SLA with fallback activity, what will happen is automatically Pega will enable you to provide these three values automatically. The moment you disable, these three values will be hidden. Now, what does the significance of these three values? As the name itself indicate, for maximum duration of service activity in millisecond means Pega will try. Basically, as you know that every time a service is getting executed, basically we are calling an activity, which we're gonna show in practical. We are basically calling an activity. Now, to execute that activity, Pega takes some time, right? Now, you can configure this time on how long you want this activity to be executed. Let's say if it goes beyond that time, then obviously you can plan your fallback activity. Now here the second point is the consecutive violation that can occur. Now let's say 3 consecutive time, if the activity takes more than 500 seconds to execute, then you can plan for a fallback activity. And the third one is the retry interval time and how long it Pega needs to wait for the next attempt. Now this enables service SLA with fallback activity when you want to do, let's say for example, if the service is failing consecutively 3 times, if I go for the default configuration which Pega provide, wherein you can change that whenever based on your need, but if I go with the default configuration here, I can say now if my service is failing or taking 500 milliseconds, more than 500 milliseconds for 3 consecutive time, I want to just send an email to the support team, right? This is what my fallback activity will have. So fallback activity, nothing but you are going to call another activity which under the fallback activity section, which I'm going to show you, and basically that activity will execute and do the necessary job. Now here how does that work is, when the service activity is not finished, right, after a configure amount of time which you configured here, like for example over here 500 seconds, and the maximum number of violations, let's say you put 3 means consecutively 3 times you 3 requests are getting delayed and taking more than 500 seconds. That means during that time this fallback activity will be automatically called. So basically depending on this configuration. Now if the next attempt is successful, then Pega will start the normal processing, but no further request will be attempted until the retry interval has passed. So that means if you whatever the time you have configured, that's a 10 second you have configured, there won't be any further request Pega will process until the time will be passed. So this is how you can configure the fallback activity. Now I hope this is clear. Now moving to the next step is the method tab, right? Now method tab is where you're gonna define all your fallback activity, request, response, the normal activity which Pega process. But on a very high level, Pega provides these 5 different methods: get, post, put, patch, and delete. Now as you might have already known from my earlier video of basic API videos, get, post, delete, and put, right? I just haven't talked about patch. Now the difference between this put and patch is, put means when you want to replace the entire object with new values, right? You are going to let's say you created a customer detail. If you want to replace this customer detail with completely a new set of values, that entire object, you're going to go for put. And if you just want to update customer first name or last name, then you can go for patch. That is the difference between put and patch. But generally in real time, depending, most likely people would be using post, people will be using put, so it's kind of everywhere. So but yeah, whenever you have a need, and depending on your organization, wherever you work, what kind of method they use, you can go for that method. There's no harm in that. Now moving to the next step. So this is how the method tab looks like. Now the first is implementation, right? This is where you are going to define the actual activity. Okay, so I just have captured one single screenshot. For each method tab, you'll have the same set of attributes. Now I have just taken one, so I'll explain where all you need to mention what. So the first thing is implementation activity, right? This implementation activity is nothing but a normal activity. Whenever you an external consumer is calling your service, that means this activity will get triggered depending on the method that you have configured. Once and this activity will process and process the request. Now once the fallback activity which I've just explained, you have selected in the processing option. That's where this fallback activity will be enabled. Now if you haven't enabled that checkbox, right, which we discussed just before the slide, then this fallback activity will not be enabled. This is where you're gonna call your fallback activity to send email or report something, or send a message or something like that. Now moving to the next one is the request and response tab. Now each request and response tab, you'll have three sections. Okay, one is header, where you can define your header, whatever header you are expecting from a consumer. The second one is your resource path parameter. Now this resource path parameter is always going to be read only. Why? Because see, this resource path parameter you would have already defined in the first tab, right? When if you remember in earlier video, in earlier discussion, I have shown you that you have defined a parameter, right? URI template, and in the parameter you have defined underneath, well, it's going to map to the clipboard and it's going to map to the param.temp, right? This is what is gonna come over here. So basically from this param.temp, now when the activity will be triggered, that means param.temp1 will already have the value. Now you can take that value and process it further. And now coming back to the query string, if your service has any query string, then you can define over here for search activity. I hope this is clear. And now moving to the next one, the response tab, right? So this is how the response tab looks like. Now we'll talk about more in detail. Now the first thing is about these three different sections is condition, response type, and the HTTP response status code. Now if you see here condition, now let's say your service can as you already as you already know or have seen my video, that we have different kind of response status code, right? 200, 400, 404. Now what we generally tell, 200 means success, 400 means you haven't passed the mandatory parameter, 404 means I can't find the detail for the request you have sent. So these things, right? So based on that, you in Pega, we are basically going to define the condition for different error code, whatever you defined in the Swagger. Now based on that, you can use those when condition over here and tell and choose the status on what kind of status you want to send. Let's say if not found, you have defined somewhere and you have created a when rule, and you can use this when rule and choose HTTP status code is 400. Let's say if it is success, you put in a property, use a when rule, and can choose H200. Now this response type can be potentially two types. One is application/JSON, another one is application/XML. Now most likely we use JSON in today's world because XMLs are heavy. But having said that, depending on again what your consumer provides or what your organization prefer, you need to go for that and then choose the response type. So if you choose response type JSON, then you're gonna send back the response in a JSON format, and if you choose response type as an XML, you're gonna send back the response as an XML format. In our practical video, I'm gonna show you and explain you and tell you how it actually works in real time, and gonna show you also the response structure. So moving to the next one, here what you define is the header. Now header completely you can define the properties, and you can tell whether you are mapping it to a constant or you are mapping it from clipboard property. Basically it's a response header. See, most likely in my experience, very rare scenario where I have seen response header. Only request header is what matters to any API request. Most likely I haven't seen, but if you have a requirement to include response header for some or other reason, you can feel free to include over here. Now coming back to the same third one, where I was just talking about map from, right? You can map from a constant value, you can pass a constant value back to the consumer, or also you can map from a clipboard depending on your calculation. Now the message data here, this is very crucial with respect to the message data. Here basically what you are doing is you are defining basically for every 200 or 400 you are going to put a description. This description is just for a read-only purpose for the Pega developer. It's not going to send back anything to consumer, but the thing which you're gonna send back to consumer is map from and map from key. Now we'll talk more about map from key. Map from basically it's a drop down where you can have different advanced section. You can map the JSON, map the XML, everything we're going to talk. Basically map from key is going to be your response object. Whatever response object you wanted to send back to the consumer, you are going to define over here, and then map from, you're gonna choose whether it's XML, whether it's JSON and all. Now the last one is if you see this plus icon, add response condition, this is where we are going to create each and every condition. Let's say if I have 200, 400, 400 for 500, I'm going to keep adding one condition and define that particular section with all the detail. Now the thing which I wanted to talk, the final one is a map from. Here you got multiple options. You can map from constant, you can map from clipboard, you can map from JSON, XML stream, all this thing. Now maybe in the practical I can take maybe one or two options, and based on that I'll show you how it is, how the response varies depending on what you choose, right? Now yeah, that's pretty much about the response tab. Now let's move to the last tab of our discussion, which is our Open API. Now in Open API you got two sections. One is YML, another one is Swagger. So whatever we have, we are going to define the request and response. Everything is going to be part of your YML. You can take this YML and put that into a Swagger editor, and you can send back the Swagger, or you can define the Swagger and send back to your consumer. So that's the end of my video, and I hope it is clear with respect to the theoretical aspect of what is the service package, what is service REST, and how they are connected, all these things. I hope you liked it, and probably in the next video it will be more interesting. The moment you understand the theoretical part, the next video it will be more interesting to understand the practical part, where you're gonna see some live action.
That's it for today, and hope you understood clearly. Please hit the like button if you learned something or you like the way I have explained, and leave me a comment if you have any queries or feedback for me. It will help me to improve and also motivate me to post more concepts and videos. As I always tell, sharing is caring, so do share with others so people who do not know about my channel will be benefited. Stay tuned for my next video, and if you haven't subscribed to my channel yet, please do subscribe and click on the bell notification for my new video updates. Thanks for watching, and see you in the next video.